The Arrhenius acid-base definition is literally the earliest acid-base definition that we've had. So when we're thinking of how we're going to define an acid and how we're going to define a base, the Arrhenius definition allows us to understand what happens when compounds are mixed with water. So an acid, when it is mixed with water, is going to yield H plus or H3O plus. Also, that acid substance has to have an H in its formula. So one example I want to bring up is HCl Hulk. As you can see, this is HCl. It has an H in its formula. And when it breaks down in water, it's going to release two ions, H plus and Cl minus, therefore yielding the H plus that helps us, of course, use this definition. Now let's go ahead and look at some actual reactions here. We have HA, which is going to represent the H that is in the formula. And then we have A here for the acid. It's going to break down to H plus and A minus. Of course, here it does not show that it's being mixed with water, but it is being mixed with water. So some folks might say, why do we use H plus or H3O plus? It's because of this fact. Either we can show it simply by not showing it being mixed with water and just showing it and writing it as H plus, which is the simplified. Or if we have that same acid, H, which you know H is in the formula, and A mixed with water, then this H is again going to be able to, this water is going to be able to accept a proton from this, as you can see, and form the hydronium ion H3O plus. So this hydronium ion is simply just H2O and another proton attached, okay, or another H plus. And then once this H plus is gone, you're going to be left with A minus, which we'll talk about as we get more definitions later on. So that is what a base is, okay? Why did I choose Hulk? Well, I just thought about Bruce Banner and his transformation into Hulk, okay? So when we have Bruce Banner, and then when he has any kind of stress or anger, he usually is going to have this boundless energy or response, which allows him to become HCl Hulk, okay? And so in my head, I'm like, okay, he's going to become HCl Hulk and he's going to release that H plus. And because he's so strong, we know that that H plus is going to be in solution. And again, we have an acid here, right? Now let's move on. We then have the Arrhenius base definition. So a base is going to have OH in its formula. So I have chosen the Black Panther, T'Challa, and as you can see, he is representing NaOH T'Challa, or NaOH Black Panther. And so as you can see, we have OH in its formula, so we know that's part of the Arrhenius definition. And then finally, when mixed with water, it's going to yield OH minus, okay? And so again, we can have H2O here. And so what's going to happen is this NaOH, just like Black Panther, he is a very strong character, right, in the Marvel universe. And so what does Black Panther have? He has his vibranium suit. And so it has the ability to absorb energy and, of course, change its properties. That's something that's really cool. And so in my head, when I thought about an Arrhenius base, I'm like, okay, well, we want to be able to make sure that we have the correct compound, like NaOH. It has the OH in it. And then when mixed with water, it will break down into Na plus and OH minus, similar to what we see in this reaction. We have M, okay, that could be a metal, it could be group 1 or group 2, and then we have OH, right? And that is going to be the OH minus or hydroxide polyatomic ion. It's going to mix with water and we get a dissociation. You have M plus, which is going to be the metal, raised to its cation level, and then of course OH minus is going to be left in solution. So when we're thinking about this and we're asking us simply for a flashcard, what is an Arrhenius acid? It has H in its formula and it's going to have H plus or H3O plus when it's mixed with water. What is an Arrhenius base? It's going to have OH in its formula and it's going to yield OH minus or the hydroxide polyatomic ion when mixed with water. Okay? And then we also can go further and talk about the Arrhenius acids and bases. So if I have the Arrhenius acid HCl here, mixed with the Arrhenius base NaOH, I'm going to produce a salt and water based on a neutralization reaction. So for me, when I'm thinking of acid and bases and how crude we learned it in 101, I feel like it's easier for us to understand the Arrhenius acid-base definition from when we're starting out here, right? Yes, we know acids are going to have H plus in solution and bases are going to have OH minus in solution. We also know they have a neutralization reaction, so it becomes very simplified at this point. But the real question becomes, can we use this definition for every acid and every base? Guess what? The answer is no. And one of the main reasons why the Arrhenius definition has a limitation is not from the acid component. You can work with the acid component. It's from the base component. There are plenty of bases. One example I can give you is like ammonia, NH3, that also have the ability to yield OH minus in solution. But as you can see, if I was to write NH3 here, NH3 does not have OH in its formula, so we cannot consider it an Arrhenius base. So then we have to ask ourselves, what can we consider something like NH3? If we know it behaves as a base and it has OH minus that is going to be produced in solution, then what do we call it? And guess what, folks? That's what we're going to get into next. We call NH3 a Bronsted-Lowry base, not an Arrhenius base. So let's get into that next.